Hi Nitin, I've made you the host, so you can start whenever you're ready.
Okay, ma'am. Thank you. Okay, we'll start. We'll move further with our revision class on physics. Starting with the question. First question for today is this. The first question, we can see that they're saying that it is being suspended in mid-air and it is being managed by, or it can balanced by a magnetic field. So we can write that the force which is going down, the magnetic force, in this case will be mg, which is again equal to the magnetic force BIL. I'm supposed to find mass of the wire. VIL upon G. Yeah, option A. Okay, fine. Good. The BIJ, when you substitute BIJ, it will be 0.5 times 2.5 times 15 to 10 raised to minus 2 upon 10, which will give you 62.5 grams. Okay, so the first option. Okay, good. Yeah, next. This is the second question. We are done with the first one. Okay, so this the second point is right. It points in the north-south direction when it is suspended. It points to north-south direction when it is suspended. The thing which is incorrect here is it doesn't produce a magnetic field. Being a magnet, it will not produce magnetic field. It's not true. It will produce magnetic field. It can produce. It have a capability of producing. If current is passed through it, it will produce. It just the only thing is behaves like a temporary magnet. It doesn't behave like a permanent magnet. Solenoid, toroid, all that behave like a permanent magnet. These behave as a temporary magnet. So it can create magnetic field. So the last option is incorrect. Next. Option C is right. Let's do a second. The time period formula is T is equal to 2 pi root over I upon MB. All the data are given to you. 2 pi is the constant value, I is given to you, M is given to you, B is given to you. I is moment of inertia. It's given. Magnetic moment, this is capital M, it is given. This is I. Magnetic field B, it's given to you. So that will give you value for one oscillation for 20 seconds, whatever you get, you have to multiply it. So it comes as 2 a second. Okay, good. You just substitute it, you will get the answer for it. Okay. Susceptibility is a parameter for finding out which have a better magnetic capability. For ferromagnetic substance, it is very high. Which have a very good magnetic property, susceptibility is very high for that. So it is too much greater than 1. Okay, anti-ferromagnetic, all that have 0. Paramagnetic have greater than 1. Less than 1, or you can say it as like 0. So it's less than 1 is diamagnetic. They will have again property which will show temporary magnets, and 0 is anti-ferromagnetic. Next question. Okay, so they're asking the magnet falls with a net acceleration, how much? So the net acceleration here will be less than c. The reason is because when this magnet is allowed to fall vertically along this axis, okay, so the north pole towards the coil. Okay, so what happens is basically the north pole goes inside, and the upper face of the coil will become what? It will be start behaving like a north pole, so that it can oppose the approaching north pole of the magnet. Okay, because it's coming down here, so this will start behaving like a north pole, so that it can repel this one. It can avoid it. Okay, so avoid this thing. Basically, the acceleration has to be less than g. This one. The magnet falls with a net acceleration. So because this goes up, this is coming down. So it will be something less than g because they are having ultra direction acceleration. So what will have, it will be g minus a. It's falling down, right? And we know that the normal force is equal to what? Mg minus l. So this is what is acceleration. The total acceleration will be something less than a, g minus a. Okay, again, theoretical question. The working of a magnetic braking of train. This is purely depends on eddy current. Okay, phenomena of induction, that braking system, the brake is basically applied. It happens because of the induced EMF, and the induced EMF leads to the formation of eddy current. Okay, next question, solve this. That solves this. Fine. So when we try to find out the potential difference, the formula for potential difference is basically equal to BLV sine theta. Basically, L is the length, magnetic field, and V is velocity. Okay. When we try to substitute the values, so V is equal to 4 into 10 raised to minus 4 Tesla. L is 20 meters. 20 meters, and this is velocity is 400 meter per second, 400 meter per second, and the angle is 30 degrees, so sine 30. So basically, when you're trying to solve this, this becomes 32,000 into 10 raised to minus 4. So into sine 30 degrees half, basically 16 0, so 1.6 volts. This is the direct formula to find out the potential difference, VLV sine theta. Yes, so you're
So in that, if angle of dip is given, then we need to use the formula of magnetic field due to vertical upon magnetic field due to horizontal. No.
that is different thing. They are asking you the dip angle directly. They have given you. Then why will try to get into that magnetic field and this thing? This is to find out to the what formula you're telling. You're telling to find out the magnetic horizontal, and this thing is to find out the angle. I already have the angle now. So why I'll try to calculate it? This angle is already I have. The angle is the angle between the components, and because it is flying horizontally, and the angle between the horizontal and vertical component. This is basically what this is basically you try to find out the y by x component, slope or something. This is math formula where you write the vertical component of an horizontal component. Already I have vertical component of a horizontal component. I'll try to find it. That's why that's directly substituting it. You can ask me the question that why theta is equal to 30 degrees, because 30 degree they have mentioned the Earth's this thing, the dip angle is 30 degree at that place. At that particular place, the dip angle here is 30 degree. So I'm directly using it. If they're telling me to find out dip angle, I'll use that formula. Okay. And AC circuit shown keeping K pressed, that means you're keeping the K on. If an iron rod is inserted into the coil, the bulb in the circuit, it glows more brightly, glows less brightly. Okay, so we have AC here, we have a coil over here that is basically inductance. Okay. A simple thing, when you are trying to insert a rod, it let it be anything. Normally what happens when you're trying to, that's resistance, or in case you can, because you have a coil, I can say that the inductance increases, because you're trying to make you're trying to put a conductor inside a coil, so it basically increases, so inductance increases. So when the inductance is nothing but you say about capacitive reactance, or you say about inductance, or you say about resistance, all this does what? It tries to decrease the quantity of charges flowing through that particular point. It's trying to decrease the flow of current. So basically what we say that if the flow of current decreases, what it will happen? The brightness will decrease. Okay. So it glows less brightly. That is what I think. Here when you're trying to insert a conductor inside a coil, or let it be anything, resistive material, capacitive material, or inductive material. If you're trying to insert a conductor inside that, may it's a rod over here, then it will increase the inductance, or it will increase the resistance, or it will increase the capacitive reactance. So because of that, the glowing of bulb will be less. Right. So the option will be B. It glows less brightly. Okay, next question. Try this easy question. Okay, that's all the questions. They're asking you to find out the value of the peak current. So value of the peak current is basically in terms of when we talk about AC circuit, because you know that I write the current as it is I naught sine omega t, where this I naught represents the peak current. This I naught represents your peak current. Peak current you say, or the highest value for the current basically. Okay, so when we are trying to find that, okay, so for the step down transformer, the value for what we try to write it, this current in the secondary coil will be equal to the power in the secondary coil by the potential difference in the secondary coil. So if I see that I have power as 12 watt and this is 48 volts, so this becomes basically 1 by 4, which is nothing but 0.25 ampere. So the current in the secondary coil is 0.25 ampere. Now to find the I naught value, I naught is basically equal to I root 2 times I naught IS, that is current in the secondary circuit. So if I'm writing that, it will be 0.25 times root 2, or I can write it as same as 1/4, because the options are not in this form. I can write this as what? This can be written as root 2 into root 2 into root 2 into root 2, which is equal to 4. And I have another root 2 on the numerator. This gets cancelled. So I get it 1 by 1 over 2 root 2. So 1 over 2 root 2 is the answer. This is the formula. This is the case for secondary current. I found it by power on the secondary circuit, by voltage, potential difference in the secondary. Substituted it, got current. And this is what is the value for I naught. Okay. Good. question. Okay, for inductive circuit, this is inductive reactor. For inductive circuit, we write tan phi is equal to omega L. You write it as XL, that is inductive reactance, XL upon R. So XL value, we basically write it as omega L upon R. Now, omega L value, directly they have given me inductance values. I can directly substitute that, which is 1 by root 3. Resistance is equal to 1. So from here, what I can write that phi is equal to tan inverse root 1 by root 3. 1 by root 3 tan inverse value is basically equal to for 30 degree. So you got this as 30 degree. Now what I can write that omega t is equal to 30 degree. The phi, the phase difference is equal to 30 degree. 30 degree in terms of radian, I can write it in terms of pi by 6. Time lag they are asking you. So I can write time lag as pi by 6 omega. Omega value, I can write omega as 2 pi nu. Omega can be written as 2 pi nu. So where f is a frequency or nu is a frequency. Whichever you feel is easy for you can write, remember that. Sometimes you get confused about omega 2 pi nu or 2 pi. It's basically same thing, frequency. Okay, so when we do this, we get it as 1 by 12 because pi gets cancelled. So I get it as 1 by 12 f. Now frequency is 50 hertz, so I can write it as 1 by 12 into 50. 2 into 5 is 60. So basically I get it as 1/600 seconds. Okay, so you just need to know that which formula is supposed to be used. Things will become easier. Please check. Next. This is a electromagnetic waves property. Direction of propagation also will be always perpendicular. Okay. So the direction of the propagation of the wave will be always when it is E cross B vector. Electric field is perpendicular to magnetic field is perpendicular to the direction of propagation. So that's okay. Next, according to Cartesian sign convention in the ray optics, all the distance are taken positive. Because all distance negative, this is wrong. It's not true. All distance are taken negative, wrong. All distance in the direction of incident are taken positive, correct? All distance in the direction. Okay, so this is wrong. Basically, this is right because all the things which is in the direction of incident ray is taken as positive, and which is opposite of the incident ray is taken as negative. For example, if you have like this, so this is how the incident ray is coming. So whatever is in this direction, all that will be taken as positive. Comes back like this. So whatever goes in this direction, like in this direction, so all this will be taken as negative. Okay, next. Okay, let's solve this. As we know that the mirror formula is 1 by f is equal to 1 by u plus 1 by b. Okay, so if I'm trying to substitute the values, radius of curvature of 15 centimeter. So r is there, so focal length will be half of that, so minus 15 upon 2. U being always negative minus 10. I'm supposed to calculate image distance v. So basically, I'll get it as 1 by v is equal to 2 by 15 negative plus 1 by 10. So LCM wise, it's I can take it as 2 times 2, and this will be into 3. That will make it 30. So 30 minus 4 plus 1. So basically gives V is equal to minus 30 centimeter. Because V is equal to minus 30 degrees, I got this. No, this is negative 30 image distance. Now I'll find out magnification because they want me to. The options are given in terms of magnified, direct, inverted, or dimmed. So I know that it has to, because see, height of the object is 10 centimeter. Okay, so if I'm trying to find out this, I can write that magnification is equal to height of image by height of object will be equal to minus V by U in terms of mirror. So I can write that height of the object is given to you. Now I can find out minus V by U will be how much? Minus V by U will be here. This is minus minus plus 30 upon U is minus 10, which gives this value is negative 3. So you can see here that I am getting HI is equal to, HI is basically equal to 30. 3 into HO, HO is 10 centimeters, it becomes 30. Negative sign here basically says is if the image, if your M value comes as negative, because HI and HO will become negative. So if M value comes negative, so we say that it's an inverted image. So that is sure that it has inverted image. And because you can see here, this is 10. The image distance is 10. The height of the object is 10 and the height of the image came at 30 centimeters. You can say that this is a magnified image. So I can say the option B is correct because it's magnified. If the magnification is positive, that is erect. And if it is negative, that is inverted. During the scattering of light, the amount of scattering is inversely proportional to the, is basically inversely proportional to 1 by, it's lambda by 4 here, fourth power of the wavelength of light. During scattering of light, Rayleigh experiment, that is known as Rayleigh. So during scattering of light, the amount of scattering is inversely proportional to the fourth power of the wavelength of light. Fourth power. Yeah, so that was right answer. Next question, this. So that was right answer because we write the width formula is d lambda d over small d. So we can see that this is directly proportional to the wavelength. So wavelength is decreasing, so interference of fringe also becomes narrower. This is interference of the fringes. The space, the width of the dark and bright pattern, that will also decrease as lambda is decreasing. Okay. Next question. Okay, anyway, this I'll tell you. This will have what? Wavelength will also decrease. So the reason is when we talk about the speed of the light in any medium, the refractive index. When I'm talking about C is the speed of light and N is the refractive index of the medium. So we write the velocity of a particular light will be equal to this. Okay. Of speed, this is the speed of the light in medium. This is the speed of the light in medium, and this is speed of the light in vacuum. Upon this is the refractive index. Okay. Also, we know that lambda is equal to what? Lambda is basically equal to velocity over frequency. Okay. So now you know that frequency of the light will be like it will stay same irrespective of the medium. The frequency of the light will remain same. So what will happen that when the light is going to move from an rarer to a denser medium, the speed of the light will decrease. Because the speed of light will decrease because of that, because you can see that lambda is proportional to what? V. This is velocity. V. Velocity of the light in any medium. This is velocity of light in any medium. So now you're seeing that if the lambda is decreasing, when it is coming from air to denser medium, so the frequency is not going to change. So I can say that the velocity changes. Now I can say that this because this lambda will also going to decrease because the velocity is decreasing. As speed decreases, lambda also decreases, right? And based on this, we can write it as what that wavelength and the speed both decreases because air is a rare medium. Rarer to denser, the speed of the light decreases because it depends directly on the medium. Because if the refractive index is more, if refractive index is more, then we say what as the speed of the light will become less. So obviously for denser medium, from this equation I'm writing. This is refractive index, right? So refractive index from rarer to denser medium. If you are moving from rarer to denser medium, refractive index value, what happens? Increases. If refractive index increases, the velocity decreases. And as I know that velocity is directly proportional to wavelength, so here velocity or speed is decreasing, so wavelength also decreases. So that's why we are writing first as option. Right. The answer is 45 degrees. The formula here is basically Malus law will say that I is equal to I naught cos square theta. So in the question, what it is there that I is equal to I naught by 2. Arises half from that of the first polarizer. So I naught cos square theta. From here I can write this gets cancelled. So I need to find out cos theta. So cos theta will become 1 by root 2. And cos theta is 1 by root 2 for theta equal to 45. This is Malus law. Okay, good. Yes. Now see, the only thing where the value of photocurrent depends, the value of photocurrent only depends on the intensity. Yoke says answer is yeah. Okay. Because it what happens is the photo current only depends on the intensity. Okay. Intensity of the light. You can see that when the intensity of light increases, there obviously simple thing is there is a metal and you're increasing the intensity. So if it is increased, so you're increasing it more intensity, so more electrons will come out and they will move in even with more kinetic energy. So like that only we want to say that the intensity is directly proportional to the photocurrent. You can see also. This is negative potential, or we say that stopping potential. So this is not changing. How you're increasing the intensity or you're decreasing the intensity. What is changing is photocurrent because number of photoelectrons, the electrons which are coming out will increase. So photocurrent also will increase because of the photoelectrons. So that's why we write that I1 is lesser than. Okay, Rutherford, the scientist who is credited for the discovery of the nucleus in an atom. Electron, Bose is just who gave you the correction for the Rutherford. Balmer is basically involved in the series of hydrogen spectrum. Balmer, Paxton, Brackett, Proof, and Humphrey. Okay, so the option is Rutherford. Good. Next, 51. Okay, option is A. Let's see. Because we need to find out the if it is moving from 2 to 4. I can directly find it when it is E2 minus E1, where E2 will be equal to 13.6 over n square, that is here 2 square, and here. So it is moving to E4. So E2 to E4. 2 square, 13.6. 4 square. So basically 13.6 outside. 16 minus 4. 16 minus of 4. So basically I'll have what? 4 minus 1 upon 16. So 13.6 into 3 by 16. 4 minus, okay. So, okay. So plus 2.5. Okay, fine, good. In the nuclear reactor, the function of the moderator is to decrease the speed of neutrons. Function of the moderator is to decrease the speed of neutrons. Okay, next question. reaction, what we have is what we have said is B. Okay. One alpha particle. Now you can see that we have uranium, so 238, and this is 92. If it loses one alpha particle, it will become what? 234, 4 and 2. It have to become 34 and 92 here. So now it became 90. So when it became 90, what I'll have here, so I need to make it 92. So to make it 92, I don't have anything directly to add it. So what I'll do, I'll take one beta emission. When I take one beta emission, it will come because of 234 and 91. No changes in case of beta emission. One more beta emission. Basically, will make it what? Uranium with 234. No changes on the top. The bottom value changes. So I can write that it should be 1 alpha and 2 betas. Because 1 alpha and 2 beta. Because we are not changing the number, the 9, we are just decreasing that 233, 238 to 234. For the 92 stays 92. That is not possible in alpha, because it's an helium atom, you have 2-4 charge there. The beta, there is no change on the top, it's only the bottom gets increases by 1. So answer should be 1 alpha and 2 beta. Yes, Suyog.
So why is that? So if we add an alpha particle, the both atomic mass and atomic number changes, but adding beta particle does not do so.
So because that's how the emission is there. Beta particle basically represents this. It is for this a beta particle, this is 0 and this one is at 1. Whenever there is a beta particle emitted, this is what is the value of beta particle. For alpha particle, it represents basically an helium atom, which is 2 and 4. So where you can see that the charge increases by 2 and mass increases by 4. Here the charge increases by 1, there is no change in the mass. So that's why we are writing it. So this is a radioactive process, radioactivity. Again, you have gamma emission also, where there will be no change itself. In that also you have negative and positive thing in beta emission, so it's not needed. Next. Okay, so to calculate binding energy is calculated as the mass effect is given to you. So mass effect 0.031 and it is multiplied to 931 to convert it into mega electron volt. So we get the value here as 27.93. Okay. Now because I have to calculate per nucleon binding energy. So per nucleon you have in nucleon we have total 4 nucleons. I'll divide it by 4, which will give me values. Nucleon is total 4 here. Nucleon is basically proton and proton and neutron, sum of neutron and proton. So I get it as 6.9 something. So one over here. Okay. The formula for binding energy is 931. I multiply to convert into mega electron volt. Okay. Okay, the energy gap in case of which of the following is less than 3 electron volt? It has to be in germanium semiconductor. Okay, in this 3 ultra transistor, which one is having? You should know that the emitter is heavily doped because it supplies large number of majority charge carriers for the current flow. Its emitter is heavily doped. Emitter is heavily doped. Now it should be large size. It has to be thin size and heavily doped. It should be heavily doped. And why we try to keep it size thin, because it is basically you sandwiched between two, which is where the base is sandwiched between your emitter and collector. So emitter is basically thin sides and heavily doped. Okay, try this. Which is universal. So NAND gate is converted as considered as, so option D. It will be considered as a universal gate. Reason is because you can derive all other gates using the universal gates. Okay, and basic communication system. First, obviously, comes information source, then comes transmitter, then channel, then receiver, then user of information. Okay, first it will be information source. So, and second should be transmitter. So option B. Okay, try this. Yeah, so answer is C. Right. Common says D. Check. Okay, let me solve. I know the value for 1 lambda is equal, 1 by lambda is equal to R. 1 N1 square minus N2 square. So N1 is the electron of hydrogen orbit jumps from the third orbit to the second. Third orbit to the second. So it is jumps from third orbit to second wavelength of the emitted radiation. So it is covering It's jumping from the first to second. I can take the n1 as this, and n2 is 3 square. So it should be 1 by 4, and it's 1 by 9. So 1 by lambda is equal to 9 minus 4 by 36 r. So basically it will be 5r by 30. So 5r by 36 is 1 by lambda value. So lambda will be equal to 36 upon 5r. So option C. Next. To a now see when I'm talking about radius of hydrogen atom, just remember that radius of hydrogen is directly proportional to n square. So if the atom is first excited level, so first excited it when it goes from 1 to 2. So because of that, so yeah, so 0.53 basically 529, so n square. So n square is basically 2 square is will be 4 times. So it should be 4 times. Answer should be 4 times. Next. Same thing. Was here relation between principal quantum number and radius just now we used. See the two type of questions. Same thing. Run two types of questions. Exact same, no difference. All this. This is fine. There's no doubt with this. So the formula is what MVR, the second orbit moment. So it will be what NH by 2 pi because it is 2 second orbit. So 2h 2 pi. 2 gets cancelled. So h by pi. Next, yes. Then the potential energy in the ground state becomes zero. Yeah, ground state of potential energy, how, but it will not have any emotion or that thing. It is not having a motion, that should not be equal to zero then. Potential energy will not be equal to zero in that case. Potential energy cannot be zero when you're talking about, because it's not moving, so it's not stationary. You potential energy will be equal to 2 times whatever energy is there. So ground state energy is this much. Potential energy will be twice of kinetic energy, twice of total energy. So it will be minus 27.2 electron volt. It is stationary, so it's not constant. It's constant, so it will have potential energy. Next. see how we find out the highest EM value. The formula for this says what is to find out this. The deflection on the y-axis is basically, you can see this is getting deflected with the respect of y-axis is given by electric field charge upon x distance to mv square, where v is the velocity. So if you're talking about all the other values constant, then we can see what is there, that y will be directly proportional to E by m, charge by mass ratio. So charge by mass ratio will be more when we are talking about the deflections, right? Now, what is there when we are talking for which the y is going to be maximum compared to this and this, for which y is going to maximum? For A, it is maximum. Y is directly proportional to E by m ratio. That's the formula. Next, what is the energy of photon whose wavelength is 6840?
Excuse me, sir.
Yes.
In question number 8, the previous question, the deflection of A and D seems to be equal, no, sir?
It seems to be equal, it's correct, but we have to choose one option out of A and D. You can choose any of them. If you write A also is correct, you write D also is correct. Because this is a previous year question and both is right for the option A and D. Because it's not clear from the diagram that from where we have to see the deflection. The exact measurement is not given. It looks like similar. So A and D for both of them, you'll get the marks.
Okay, sir.
Okay, A is the right answer. Formula is directly E is equal to hc by lambda. Just substitute the values and you'll get the answer. That's okay. Maybe you would have done some small calculation mistake. You'll get the answer as 1.8. Next. See, for the Lyman series, they are asking, so the Lyman series N1 is basically equal to 1 and N2 is basically equal to 2. So they are asking what is the wavelength of the least energetic. You have to write it in the form of 1 by lambda r this 1 by N1 square minus 1 by. They're asking you what wavelength of least energetic. It goes only the least energetic has to be this. Okay, so when you're trying to find it in terms of wavelength, you get it as this thing, wavelength, in terms of Armstrong. So nanometer, one less. So this, which will be 121.6. So you can take it as 122 nanometer. You should know this first. N1, Lyman, Balmer, Paschen, bracket, Coefficient. That's one based on that. Next. the shortest N1 is equal to 1. Oh, that is for longest. Longest will be shortest we just did. N1 is equal to 1 and N2 equal to 2. Longest is N1 equal to 1 and N2 is equal to infinity. This comes something around 121 to 13 Armstrong, and this comes something around 910 Armstrong. This is what is the longest. Wavelength, the longest wavelength. Shortest and less energy means that. This is also in the condition. Longest wavelength is N1 is equal to N2. Oh no, yeah, correct. So this will be a lambda because they're having energy. So yeah, maximum. Yes, your right answer is right. Correct. Next. See, if I'm talking about the first line of Balmer series, again I can write it as in the form of that 1 by lambda 1 is equal to RHC. For the first line, we write it as 1 square. For hydrogen, Z, because here Z will come, so Z is equal to 1, so I'm not writing it for the hydrogen. Okay, I'm not writing it for hydrogen, so I write it like this. This is for hydrogen. And this is for the second, equal to the second line of the Balmer series for a hydrogen-like ion. Okay, so hydrogen-like, I consider it to Z square, I leave it there, and then 1 by then, because it's a Balmer series, so N1 starts from 2. Okay, and this is second line of the Balmer series, right? Second line of the Balmer series. So it has to be 2 to 4. So because the question says that lambda 1 is equal to lambda 2, so we can write it as what? That just equate of them. 1 by 1 minus 1 by 4 equals to, yeah, so 1 by 1 is equal to, then this and this gets divided. So basically 1 by 1, so 1 by z square, 1 by 4 minus 1 by 16. So yeah, 2, yeah, so that is equal to nitrogen like that. Right. Try to solve few more questions. So the first question here is, you need to find out kinetic energy of an electron. Kinetic energy of an electron, which is accelerated with a potential difference of 100 volt. You need to find out kinetic energy of an electron, which is accelerated with a potential difference of 100 volts. Question number 1. Try to solve this. (1.6 into 10 raised to minus 7). Right. The formula directly you have to use as what as Q into V. Correct. Next. Next question says is, you have a light whose wavelength is 400 Armstrong, sorry, 4000 Armstrong, and it have a metal have the work function as 2 electron volt. So they're asking you what will be the kinetic energy maximum. Okay, 1.1 electron volt. Okay, right. So we basically have what is, I know that formula will be what, Hc by lambda equals to work function plus kinetic energy maximum. If I have to find out kinetic energy maximum, I can write it as kinetic energy max Hc by lambda minus phi naught. Hc basically in terms of electron volt, if you want to write it, Hc is equal to 1240 electron volt. You can directly substitute. So answer you will, the answer is right. It will be 1.1 electron volt. Okay, so this is what is the work function. Work function is basically what, minimum amount of energy required for the ejection of electron from a metal surface. So that's what is. Okay. Let's go to the next question. We have a simple pendulum which is executing SHM, whose time period is T. Time period is T. Next, what is given is length of the pendulum is increased. Length of the pendulum is increased by 21%. Okay. So what will be the new time period? What will be the new time period? We have option 22%, 13%, 50%, 10%. So answer we got is 20. Okay, so we have an answer as 22%. See, now what I know is T is equal to 2 pi root under L over G. So if I square both the sides, it will become basically T square 4 pi square L upon G. Now because they have given us what? They have given us basically the change, the increase, the L is increased by 21%. So what we'll do is basically differentiate this. So I'll get the form with respect to time. So I'll get this in this form. This is 0. Then so I'll get it as again G is also 0. So I'll basically get it as this minus 0. Again L square will get cancelled, so we'll not get into that by A. This is U by V. So basically what I'm getting is dt by T is equal to 1 by 2 dl. This is length, dl by l. Now what does a L is increased by 21%. L is increased by 21%. So now I am talking about 21% is 1 by 2 into dl by l. So this first side multiply this side by 100. So this is this also by 100. So it gets converted into. So now dl by dl, this is basically equal to 21%. This is basically equal to 21%. So 1 by 2 of 20% is basically 10.5. 10.5% is not there in the option. Closest is 10%. So the answer for that will become 10%. Next question. We have an iron rod. Iron rod, the length is 2 meters. Iron rod length is 2 meters. Cross sectional area is 50 mm square. 50 mm square. It is stretched, so delta x, so change in length, or you can write whatever you would denote it. Basically, this represents the extension. Once you put the load, the extension is equal to 0.5 mm. When you're putting a load of 250 kg at the lower end of the iron rod, you need to find out what is its Young's modulus. Young's modulus is how much? Young's modulus. Two into 10 raised to power 11. Okay. Yeah, you can write it as 2. Okay. Okay. So it's basically nearer to 2. I will just substitute this in the formula. So formula for this will be what? Young's modulus is basically equal to force upon area upon delta x by L, or x you write. The force is given to you. You can convert the mass into acceleration. So 10 into area is given to your cross sectional area. So 15 to 10 raised to minus 6. Then I have delta x by x is equal to basically I have uh, 2 meters. Delta x is equal to 0.5. So 0.5 to 10 raised to minus 3. Only this much is there. This is what will be Young's modulus. Let's go to the next question. What is given is the escape velocity of the body when it is projected from the Earth's surface. That is escape velocity is 11.2 kilometer per second. It has to be this much. Okay. If it is projected at angle 50 degrees from the horizontal, if there is a situation that what we are trying to do is we are throwing a body with an where it is making an angle of 50 degree with the horizontal. Okay, it is making a 50 degree from the horizontal, then you have to find out in this situation what will be the v. Question is basically that the escape velocity is equal to 11.2 from the Earth's surface. Now what we are doing with the horizontal of the Earth, with an horizontal, where horizontally it is making an angle 50 degree. That time what will be the escape velocity for that object? Okay, so it will be still stay same. because it is independent of the angle of projection. It is only dependent on the gravitational pull. So angle of projection, let it be whatever, it is only dependent on the gravitational force, nothing else. Okay. Next question is, the radius of Earth is around 6,400 kilometers. The radius of Earth is 6,400 kilometers, and that radius of Mars is equal to almost 3,200 kilometers. And mass of Earth is equal to 10 times. Mass of the Earth is about 10 times of the mass of Mars. Okay, this is what is a normal relation. Okay, this is normal relation. The next line says is the object weighs 200 Newton on Earth's surface. Okay, so you need to find what is, you need to find out the weight of the same object, on Mars surface. On the surface of Mars, how much will be its weight? Okay, so see, in this, basically what is there, we know the value for this. If I want to find small g is basically equal to gm by r square. Okay, so now if I'm trying to find out the value of g on Mars, so it will be basically what, it will be g m. Okay, r, you can see that here it is, r is half and mass is 10, so I can write it as m by 10, and Earth's surface, so g m e r e. Okay, this is there. So when you substitute this, you get g value is equal to 2 times 5 g on Earth, so g dash, this is basically on Mars. So now once you got the g value, you can find out the weight. So weight on this will be what, mg dash. So mg will be how much? So basically it will become what, 200 times 5 by 2. So this will become 80 Newton. So this is how basically, so everything interrelates to the g value. Okay. Anyway, you all keep on studying. Just keep on continuing like this. Just keep on your hard work working. Okay. So we'll have another session on chemistry tomorrow. Okay. This is it for today's class. Thank you.